Welcome everybody, we are back again with Felsefes in the YouTube channel. Today's video will be Mathematics, IBDP Mathematics AA Calculus number 3, episode 3. It is about integration, and this will be an excellent video, I believe, because today we have Ege with us. Hello Ege, how are you?
Hello guys, what's up?
I hope and we hope everything is fine with you. So in today's class we will be discussing more about integrations, and then there will be some new concepts, including like things integration by parts and etc., which were not actually in the IGCSE curriculum. Therefore we will discover new things and we hope it will be fun. Shall we start again?
Let's start.
So today's concept is integration, and again we'll make a brief introduction to this, and we'll talk to you about some basic rules that you should know.
Okay, let me come back to that. Alright, so guys, you may not have known about integration, but let's talk about the integration first. What integration means, okay? Well, integration means that as we find the integration of a function, we can find the area of it between two intervals, or between two functions, or above a curve or below a curve. We will be talking about them more, but firstly, we need to know how to integrate, right? So let's come back to that. Okay, there are some certain rules, and also, guys, it is also known as anti-differentiation. So if you take the differentiation of an integration, what will happen? You will get the function itself. Okay, and you will see what I mean when we solve examples. Okay, so let's look at the first rule. Yeah, these rules are important, and this will make our lives easier. Firstly, we have a constant k, and we can take the constant out of the integration. Or if we are taking the integration of two functions, addition of two functions, then we can just separate them and add them together. It will not change the result. And also, let's take a look at general rule of integration. Okay. So as we have x to the power of n times dx, and you should add dx because you are integrating with respect to x, not with respect to n. N is our constant here. Okay. And it is equal to x to the power of n plus 1 over n plus c. Okay, plus c is constant of integration. We will be talking about that, but let's see the first part. As we see the first part, if you take the derivative of it, okay, we will be having this, isn't it? Are we not? Okay, let me write it. If we take the integration of it, we will have n plus 1, and we reduce the power by 1, and it's going to be n, over, also as an extra we have n plus 1. And these will cancel each other, and at the end, we will have the function itself. So it is known as anti-differentiation. Guys, can you see my writing?
Yeah, I guess we cannot see it right now, right? What about just annotating it for now? Would it be fine?
You should be able to see it now.
Okay, let me see. Let me just synchronize it once again to make sure everything
is. Should be great.
Okay.
Also, your charge is low, I think.
Okay, I will just deal with it. You are writing on the page that we are recently on now, right?
I am on the page.
Okay. Let's see.
Well, let me just write it again.
Okay.
Sorry guys for the technical difficulties.
Yes. iPad Pro.
Gülşah Hoca'ya Gülşah Hocam please help us.
Gülşah Hocam, iPad Pro please. Yeah, I tried it, but it still seems not to be working.
Okay. No problem. No problem. Okay. And as I told you before, it is the anti-differentiation. Okay?
Yeah, and I let you annotate just in case if you would like to use that option.
All right. Okay. Thank you very much.
You're welcome.
Okay. So let's look at our second rule. Okay. And it is that if we take the integration of 1 over x times dx, and you should put dx too, in order to be mathematically correct. The examiner will understand what you mean, but let's be correct mathematically, okay? And it's going to be useful for your university as well. And it is equal to ln in absolute value x plus c. And if we take the derivative of ln x, then we will find 1 over x. And Brock actually told why the differentiation of ln x is 1 over x in our previous video on differentiation. So you can take a look at it before you continue with integration. Okay, let's solve our first example.
Just a second.
Yeah,
1 second, please. I guess it will work now. I think you should be able to write on it now.
Okay. Well, I am writing now. Can you see that? Wait a sec. No, I'm writing on the first example.
Okay. Not
First
really.
example. Okay, I will annotate.
Okay.
No problem. Okay, let me annotate. Alright. So let's look at the first example, okay? So we are given our function and it asks us to integrate with respect to x, okay? So, as we said before, we can write minus 2. I'm writing, let me write with which color? Minus 2 plus x, but we have an extra, we have to add 1 to the power, right? And also, guys, if you take the differentiation of it, you will find minus 8 plus x, x cubed, right? But you have to eliminate 4 there so that you can have minus 2x cubed for your initial function in the integration. So we have to add 4, and this is the logic of the first rule actually. The first rule I told you about. And it's in the formula booklet, you don't have to memorize, okay? So we have also 5x, okay? And if you take the integration of it, you will have 5x squared over 2. That if we take the integration of it, we will find 5x, okay? So we have to put over 2 that. It is very important. And if we have minus 2, okay? Minus 2, and it is simply minus 2x. Just try to think in terms of differentiation. It could be easier. Okay. So, and also we have plus c. Please do not forget it. And this is going to be very important in the next following concepts, the concept of integration.
And this is a mark in IB.
Yes, this is 1 mark actually. Yes, bro. Thank you for reminding me. It is very important. And why it is important, guys? Let me tell you about it. So, let's say you put 7 here, okay? You put 7 here, but if you take the differentiation of it, it's going to be 0, right? If you, let's say, bro, can you tell me a number?
Okay, 4.
4. If you put 4 here, it's going to be 0 too.
Yep.
So you cannot find the function itself. You cannot find this value by not having more details about the function. So we put c here. It is also constant and also unknown. Okay. Okay. Let me delete it. We solved it. Okay. So let's pass to the second example. Okay. In the second example, as you can see, we have 5ex plus 2 over in square root x and times dx. You should put dx. So we know that the differentiation of ex is not changed if there is no function in its power. So we put 5ex, and if you actually take the differentiation of 5ex, it's going to give 5ex, so it is correct. And plus, so this part is a bit tricky, but if you remember the rule, it will be easy. It could be hard to think in terms of differentiation here, but if you apply the rule, you will see that it is easy. Okay, so we have minus over 2 firstly, and we have that 1, right? But over, in order to get rid of minus 1 over 2, when we differentiate, we have to put minus 1 over 2 here too. So when we simplify it, we will find that it is 4 times in square root x plus c. Do not forget c here. I think that's clear.
Yeah.
Burak, do our viewers have any questions?
I haven't seen so far, except for a hi.
Okay.
Okay, should I scroll down?
Yes, please.
Just a second, okay. Another example, right?
Yes.
Okay.
It is another example. Burak, could you? Yes, thank you. Alright, so this part is a bit tricky. Why it is tricky? You have to remember the differentiation of arctangent x or secant x, but you have them in the data booklet, right? Let me open my data booklet, formula booklet, sorry, I confused it with science booklet. In topic 5, in page 12, you can see the series of standard derivatives, okay? You can see them in formula booklet, and if you take the reverse of it, as I told you in the beginning of the video, if you take the integration of a differentiation, you will find the function itself, yeah? Or the vice versa. So as you can see, if you take the differentiation of arctangent x, you will find 1 over 1 plus x squared. So this is simple, and you have to remind yourself about it, because these kinds of questions may come up in IB, and you may be like, like how are we going to integrate it? And it could seem very complicated, but actually it's not. Okay, let's solve the first question. It's going to be easy. Okay, it's asking us to integrate 2 secant x times tangent x minus 1 minus 6 over 1 plus x squared. Okay, so we know that secant x times tangent x is equal to the integration of it is equal to secant x, right? But we said that 2 does not change here, because also if we take the integration, we have secant x, but 2 will stay the same. It's not changing. So it is 2 times secant x minus. Okay, so this part could be tricky. We know that the integration of arctangent is 1 over 1 plus x squared. But we don't have 6 in the function itself. We are looking, okay, everything is perfectly clear. If we write this function like this, times 6, then you can see that this part is actually arctangent x. Just try to manipulate your equations, okay? Just don't be confused by them. Just try to manipulate them. Okay. Let's pass to
and this should not actually appear in this form. I mean, in the IB, they don't usually ask like, find this one. You will be perhaps solving either Maclaurin expansion or binomial expansion, or either doing some substitution, partial fractions, and you will come across it. And if you don't say it, it is impossible for you to reach that answer, because you cannot come from a polynomial level to a trigonometric level by just using a simple IB method.
Exactly. These kinds of questions do not come up in IB, but they ask these integrations mixed.
Definitely.
These are like very zero level for IB, let's say, but we are learning the basics here. Okay, Burak, could you let me annotate?
Yep, sure.
Alright. So particular values, and this is the part, and these kinds of questions come up in IB. This is the part where we find the constant of integration. Yeah. Okay, let's take a look at it. It asks us to find the function fx, given that it gives us the differentiation and also some information, additional information about the function. And this is the part where I was talking about finding c, right? You have to have additional information. So c could be anything, but it gives us additional information. This is the tricky part. Okay, so we are taking the integration of the derivative, yeah. And when we take it, we will find that, for example, let's take the integration of it. X 3 plus 1 is 4 over 4, yeah. Minus 2x 2 plus 1, which is 3. And let me erase it. It's not good. Okay. Over 3 and plus 2x plus 6. And this is our fx, right? But it already gave us some information. It says that if we put 0, let me write it with a different color. Make it clear. Which color we will put it if we put 0 here, 0, you will find that 0 minus 0 plus 0 and plus c is equal to 2. So you can find that c is actually equal to 2. And at the end, we find c here. And if we just write the whole equation, then 4 marks. And this is the part where we find function. Perfect. Okay, right. Let's solve the next question. And I think that will be all for me. Alright.
Let me clear that. By the way, Ege, can there be any problem about your microphone? Is it possible?
Really?
Yeah, I mean, it's a little bit silent.
Silent?
Yeah, it's a little bit low volume.
Oh, I see the cause of the problem. Okay, wait.
Okay.
Audio settings. Okay, is it good now? Is it alright?
I think it's better. It's much better, I think.
Okay. Alright. So, let's solve the tricky question. It's not tricky, but it's a bit long. So, okay, let's start. So, it asks us the function fx, given that it gave us the second derivative. This is the part where Burak was talking about in the last video, previous video. You can check it out in the YouTube channel. And it gave us the first derivative and also some information about the function. Okay, if we take the integration of the second derivative, we will find f prime. And we will find the second information. Okay, let's take the derivative. Let's take the integration. Second derivative. And we find that is 4x cubed minus 4x plus c. This is the part, okay? And it gave us some information. It says that if we put 0 in the place of x, then we will find 1. If we put 0 here, then we will find that c is actually 1. I made a mistake. Did I make a mistake? Oh, it is minus 1. Sorry. Very sorry. I wrote the data incorrectly. C is not minus 1, it is 1. Sorry. Sorry.
Just a second, please. Okay. Everything fine?
Yeah. Yes, sir. Thank you very much.
No problem.
Okay, I wrote it incorrectly, guys. Sorry for I will fix it in the Okay, I will fix it. Okay, so we find our first derivative, the function of first derivative, okay? And if we find, if we integrate our first derivative, then we will find function, the function itself. If we take its derivative, okay, let's do it together. Okay? 4x to the power of 4 over 4, yes. And then we have minus 4x squared over 2. And if you take the differentiation of it, you will find that you have the original function here. Perfect. Then we have minus x also plus c. This is our fx. Alright. So this, it's not minus x, sorry, it is plus x. I made that mistake again. I mean, the mistake continues. Okay. Okay, so if you put 1 in the place of x, let's put 1, 1, 1. You will find that v1 minus 1 over 2 plus 1 plus c is equal to 4. And at the end, we will find that c is equal to 3 over 2. Right? So we will find our last equation. Right, could you move down?
Yep. Let me do it like this.
Okay, it's not actually plus 6 because I made that mistake at first. It is 3 over 2. It's not 6. Let me correct it again.
Should I clear the canvas?
Yes.
Okay.
Yes. Okay, so at the end we find that c is 3 over 2, and this is because of the mistake I did when I was solving it. No problem with that, we find the correct solution. Okay. Okay, this is the end for me for now, and Burak will continue.
Okay, so I will start with partial fractions, okay? Partial fractions. Well, we may remember it from previous chapters, obviously, because it is just familiar. Should I just show this part again? Those are like common rules about the integrating part, right?
Sorry, I okay, Burak, I forgot to talk about this.
Okay, let me just show it.
Okay, could you let me annotate? This part is easy, but we have to remind ourselves of the differentiation here. Could you let me annotate? Okay, thanks. Okay, so if we take the differentiation of ax plus b power of n, okay guys, let's think. If you take the differentiation of such a function, then you will firstly multiply it with n, and then take the derivative of the inside function, right? Like, it is chain rule. This is the part where we talked in the previous live video. You can check it out from differentiation. And as you can see, this is our rule actually. If you want to have this function at the end, you have to take the integration here firstly. And let's say if you take the differentiation here, is n plus 1, n plus 1 will cancel each other, and then we will have ax plus b n, but as you remember in the chain rule, we have to take the derivative of the inside function also. So it is a, but in the original function we don't have it, right? So we have to divide it by a, as you can see here. This is the logic, guys. This is the logic. Please do not memorize this. Please.
Exactly.
And also, memorization will not take you so far. And if you understand the like true logic behind them. You don't have to memorize anything actually. You just have to analyze these questions. Okay, let's take integration of the cosine. And if you take the differentiation of sine, it will be cosine. But if you take the differentiation of cosine, it will be minus sine, right? This is the logic differentiation. I will not talk about chain rule, as I talked about it previously, and this is the logic. Oh, let me talk about the last one, 1 over ax plus b. It is 1 over a times ln ax plus b plus c. Okay, if you take the differentiation of ln ax plus b, wait a sec, or yes, ax plus b, we take the differentiation of it, you will have at the bottom you write the function itself, but at the top if you write the differentiation, which is a, but in the original function, as you can see, we don't have the we don't have the a at the top, so we have to divide it by 1 over. We have to multiply it with 1 over a, so that these will cancel each other, and at the original function in the integration we will have 1 over ax plus b. This is the logic.
Yeah. That's why we call it antiderivatives.
Yes. And let's not solve that question. You can access these examples from felsefesinde.weaksite.com, and you can grab your Felsefesinde card there and have exclusive content.
Definitely. So should I now take on with the partial fractions?
Yes.
Okay, so let me go with the partial fractions over here, okay? So when we say a partial fraction, just remember the previous chapters. Well, the first thing that I can really mention about is that let's remember how we used to solve partial fractions and how it will contribute to our knowledge about integrals. So the first thing that I would like to write is that let's assume we have 7 over x squared minus 1, okay? So can we not say that this is actually can be written in the form of partial fractions, meaning that a over something plus b over something. Now, I came to know that this can be written as x minus 1 times x plus 1, right? So I can say this is x minus 1 and this is x plus 1. Therefore, I can carry this knowledge forward and say that hence a times x plus 1, I'm just cross multiplying it, is equal to, and plus b times x minus 1 is equal to 7. Why? Because in the numerator previously I had 7. So cross multiply, add them up, and reach the numerator, previous numerator. Now we will just try to make the two terms equal to 0. Let's say x is equal to 1, okay? When we say x is equal to 1, we came to know that 2a is equal to 7, hence a is 7 over 2. Now let's just say the opposite. X is equal to negative 1. To make the a part equal to 0 to solve for b, and therefore I will just say that negative 2b will be equal to 7, therefore my b is negative 7 over 2. Hence I can say that for this part over here, 7 over 2 x minus 1 plus, or let's say directly minus, since I have the minus over here, minus 7 over 2 x plus 1 will be as equal as saying 7 over x squared minus 1. This is how we used to solve partial fractions, right? So now let's use this knowledge. But why? Let me show you a question. Let's say that we have an example like this. Our example says, please integrate, find let's put an integral and say 7x minus 1 over 2x squared minus x minus 1. Again, do you think you can integrate this directly?
No, it will be very painful.
Very painful, literally painful. So let me just take this here. I will say 2x squared minus x minus 1 is equal to what? Let's do it. 2x and x, and then we will say negative 1 and 1. Therefore, I realize that this is actually equal to 2x plus 1 times x minus 1. Since they just match in this direction, so just cross use them. And I can say 7x minus 1 over 2x squared minus x minus 1, right? Now, I will say I want to write them in partial fractions form to make it much easier, because I know that I have the feeling that my answer is going to the ln function. It's going to the ln function. I can feel that, because as I write it in the partial fraction form, I will have an ln function, since it is being in the how can I say, fraction form. 2x plus 1 and x minus 1. So let's say a over 2x plus 1 plus b over x minus 1. Now, let me solve that part over here. This is the part where I'll be using partial fractions. So let's see. A times x minus 1 plus b times 2x plus 1 should be equal to what? Of course, 7x minus 1. Where did it come from? It is coming from the initial numerator. It should be equal to that due to the cross multiplication. So let's say to solve a, we say x is equal to 1. When we say x is equal to 1, we realize that 3b is equal to 6. Therefore, b is 2. The first thing that I've known. Then let's say to solve for b, we will say x is equal to negative 1/2, right? Well, when I say it is equal to how can I say, negative 1/2, I will come to know that it will be negative 3 over 2a is equal to negative 9 over 2. Therefore, my a, I'm just substituting negative 1/2 into the equation, and my a will be equal to 3. Okay, so therefore, again, can we here say that after knowing all those things, by proclaiming this, I'm saying that my equation was in fact 3 over 2x plus 1 plus 2 over x minus 1. Is this right?
Yep.
So let's say dx over here, and now integrated. Okay, now integrated. Okay, so I will use the identities that were stated by Ege. I know that 3 over 2x plus 1 it says. So I will just say, you may see that this is the ln part, okay? ln part. If I take ln in absolute value 2x plus 1, again, if I integrate this, wouldn't it be 2 over 2x plus 1?
I think you meant to say
differentiate.
Yes.
So
yes,
I should eliminate 2 and replace it by 3, right? So I should divide it by 2 and multiply it by 3 to have this one in the differentiation. Okay, I'm just using the relationship between integration and derivation being antiderivatives and anti-integration. Okay, so plus the same thing, 2 over x minus 1. So if I said ln x minus 1, this means if I differentiate it, it would be 1 over x minus 1, right? But I have to reach 2 over x minus 1. So I do multiplication by 2. However, again, did I forget something? Yes, I did. Plus
C.
Very important. What can I do? And this is the final answer that I reach. So this is the thing about using the partial fractions. Now I will carry on here with integration by substitution. This is an important concept, just to make our jobs easier. Actually, I realized that I took the parts which make integration easier. So just focus on the concepts that will make your integration more complex and then try to simplify them. Let's write the title: Integration by Substitution. Okay. Now, in this part, I will just give you a general rule. Okay. I will just give you a general rule. Or I could actually go on with an example as well. Okay, I will just carry on with an example. Let's say, directly an example. If I was given this one, find the integral, let's say find the integral of, let's say x squared plus 3x to the power, let's say 4, okay, to the power 4. Times 2x plus 3 dx. Can you solve it again? You can't, right? If you were to carry on the knowledge that you have claimed until now by watching our live videos, probably you would be confused. Therefore, I will say, I just saw that the thing with this 4 exponents is actually the integrated version of this one. I should be able to see this, but how? So we will say that we will try to use this one, fux. Okay, we will try to reach that form.
Burak, I have to stop you because we are running out of time.
We will just switch between the Zoom links. Okay, we will be back in a second. Please do not. Alright, we are back. I hope you are not lost. Again, you know the Zoom thingy. I assume that we have the same people on the live video, so you're already familiar with the situation that we are struggling with. So I will say I have to reach that form. But to reach that form, I will say that my u will be equal to x squared plus 3x, and therefore I will say my fu will be equal to u to the power 4. Now I solve all those things. Let's say ux for this one. I have just put that in here. Now when I do this, I will realize that my function will become, my problem will become u to the power 4 times 2x plus 3 dx, right? Now again, you know that if I take du over dx from here, what do I see? Isn't it 2x plus 3? It is, right?
Yeah. Yes.
Now I see that I have dx over here, right? Well, I have dx over here, so let me just make it into this form. Dx is equal to du over 2x plus 3, right? Well, I can substitute it. Let's use it all over here. It will be integral of u to the power 4 times 2x plus 3 and instead of dx, now I will write this expression, du over 2x plus 3. Did you see again?
Yes,
this 2x plus 3,
tricky.
This 2x plus 3 is not a deal anymore. We do not have to care about that anymore. So this is the knowledge that we will be using while differentiating it. So now it will be equal to u to the 4 du, right? We know how to differentiate it, don't we? U to the power 5 over 5 plus c. And what did we say for u? Didn't we say x squared plus 3x over 5 plus c? Now, again, I think our viewers may be confused, but let me tell you which one to choose. Now, they may say, okay, but why didn't you say, for example, 2x plus 3 is u? Why didn't you say this? Because in u substitution, the concept that you have to understand is that the derivative of the u that you choose has to be present in the equation, okay? The derivative of the u that you have chosen must be in the equation. I said this is u, okay? I said this is u. Why did I say this is u? Because the derivative of u will be, the derivative of x squared plus 3x will be 2x plus 3. 2x plus 3. Now, I will solve an example in which you will say that, wow, I can play with the inside of the integral and convert my equation into the side that I would like to. Let's see how I do it. This is why we say be analytical, not memoritical, okay? Example. Try to catch those points so that you learn how to solve every single question, not one type of question. It says find the integral of that is enough, x e to the power 1 minus x squared dx. Well, this seems complex, right? Now see what I will do. Okay, I see that in the exponential of e, I have 1 minus x squared, right? Again, can you differentiate 1 minus x squared?
And it will be just minus 2x.
Minus 2x. Well, I have an x here, right? I have an x here. But I don't want to leave anything behind. Would you allow me to write it in this form? Let me say, okay, this is a good color. I will just say this is negative 1/2 times negative 2x. Is this equal to x? This is x, right? This is x. So I will continue writing it. I will say e to the power 1 minus x squared. So why did I do this? Now, if I play with my integral, I got minus 2x over here. And if I call this one u, 1 minus x squared as u, what is the derivative of my u? It is negative 2x, right? Negative 2x. I catch it. I catch it over here. And here. The derivative of 1 minus x squared is negative 2x. So now, let's use an identity that Ege showed us previously. Ege, so we can say that negative 1/2 integral minus 2x e to the power 1 minus x squared. So again, we said if we have a coefficient, we can just take it out directly, right?
Yeah.
Because it is a coefficient, cannot do anything. It doesn't have an x component together with it, so cannot do anything. I took it out, and now I will say it is time to call my u to be 1 minus x squared. 1 minus x squared. Okay, let's write it accordingly by using this, okay, by using this substitution. Negative 1/2 integral negative 2x e to the power u, let me write dx for all of them, dx. Okay, so I know that if I write by doing this, what is my du over dx? it is negative 2x, right? And I know that negative 2x is also here. So let's say dx is equal to, I'm just changing their positions, du over negative 2x. So you realize that the reason why I am saying that see the derivative of your u being present in the equation is that because when you switch the position of dx and its derivative, it will come to denominator, and when you substitute it with dx, since it will be in the denominator, they will cancel each other out. This is the only reason why I am telling you this. Now let's arrange it again. Negative 1/2 integral negative 2x e to the power u. Now for this one I will just write this one for dx, and for dx, as I said, du over negative 2x. Again we are lucky, right? Because we can have negative 2x cancel each other out. We are very lucky. Then it will be equal to negative 1/2 e to the u du. Okay, Ege said us that if we want to differentiate this one, integrate this one, we will just use negative 1/2 eu plus c. Since it is EU, e to the power x equations are very easy to differentiate and integrate all at the same time, so we don't have much of a problem. And now at the end what I am going to do is equal to negative 1/2 e to the power, what was my u? My u was 1 minus x squared plus c. Anything that you haven't understood? I hope everything is clear, right? Is it crystal clear?
You can write it in the chat session, guys. Do not hesitate. You can ask anything in the chat session. We can answer it right now.
Should you have any questions, just ask it, no problem. Just try to see the derivative of u being present in the equation. This is how you use the u substitution. This is it. And they are pretty obvious actually. They are all the time pretty obvious. By the way, again, I have to tell you that if they were also not able to see that x can be written in this form, it would be fine also, right? Because anyhow, they would anyhow will be able to cancel this x, okay? This x would still cancel this x. You would only have it in the equation. Okay, only in the equation.
I was actually thinking about it at first time. Did we have to do it? We didn't have to do it, but we made our job easier.
Yeah, I mean, this is to understand the logic. I mean, the use substitution logic. The very core part.
And Burak, I want to add something.
Yeah.
In IB questions, you don't, sometimes in such functions, they put hard, like, functions that which is hard to find the substitution.
Yes.
The u. So they give you the substitution, what to substitute with.
Definitely.
So that is, so you don't need to worry about it actually. Just know the simple ones. Just know the method that Burak showed you, and it will come very natural to you in the exam, because they will most probably give you the substitution.
So by the way, I'm just showing it very quickly. It would be like du over negative 2x, right? So x's would cancel each other, okay? I'm just showing what would happen if we didn't use this, okay? The green part. It would be just like EU.
Burak, we have a question from Dragonization Edits Öztürk.
Yeah.
What is the logic behind having C always?
We actually talked about it previously, but should I also say it again?
Yes, please, Burak. Edits Öztürk, I will call you Öztürk if you okay with it.
Okay.
We mentioned it in the beginning of the video. You can go back to the beginning of the video and understand the logic behind integration. But we showed why we need to have C always. But you can briefly mention it if you want.
But the basic thing is that, let's imagine that we have an integral, okay? We have something like, we have something like x squared plus x plus 1. If I was to differentiate this one like this, the 1 would be lost, right? The 1 over here would be lost. It would be 0. Differentiation of any constant value is 0. So while we are doing antiderivative, meaning integration, we have to find this one. This one here, we are looking for the constant. This is the reason why we are using it. The derivative of a constant will be 0. We don't want to have a 0 because this exists. But we cannot find it since it doesn't have an x component, because we are only integrating the things that have the x component. We are saying integrate according to something dx. So this is the reason why we are writing the answer, then saying plus c, because plus c does not have an x component, but we know that it exists. Even if it is 0, you have to write it. Even if it is 0, you have to write it. This is the reason. Was the good explanation again?
Yes. Thank you.
Thank
you for that.
Okay, so shall we go with the integration by parts, I guess, right?
Alright, yes.
Now, something a little bit tough is coming, let's say.
It is tough. I mean, it's not really tough, but it is a bit challenging.
Let's say it is emerging. It is emerging, okay? It is brand new. That's why it could be challenging. It's brand new. Let's see what it is. By the way,
a very good
if you have any IB physics students, HL students, okay, integration by parts helps you a lot while understanding some concepts. For example, again, do you remember solving Schrödinger's equations or Heisenberg equation?
Oh, right.
Well, you do not do these equations in IB HL physics. However, you come across them, okay, in the book, in the textbook, or some videos. They say that, okay, this is how we discovered it. But as you start to see them, you realize that everything happens by that. This is why we say that mathematics and calculus are very, very important. So what we suggest is that while you are solving IB math questions or IGCSE math questions or any kind of math questions, just be aware of the fact that this is not the top level of mathematics that you can even reach to. There are many other concepts. There are multivariable calculus concepts and topology, etc. and etc. So just beware that the mathematics takes you to another level. Even knowing mathematics in chemistry will help you a lot, or physics, or biology, or anything. That's why this is very, very important. Let's start with integration by parts, which will help us a lot in further coming parts.
Alright, let's start. Burak, let's check if you can see my writing.
Okay, let's see. Yeah, we can.
Yeah,
great.
Perfect. Alright, guys, so in integration by parts, this is the part where we cannot use substitution, where we cannot use any kind of integration techniques you may have known before. This is a new concept, and this is the rule. Let's read our rules, okay? So we have two functions, okay, u and v. The given function is given like this in the left hand side, and then it is u times v minus in the integration v times du over dx times dx, and it means that we are integrating with respect to x. Okay, so you may ask, how do we assign functions to u or v, the functions? Okay, so there is a method. There is a very simple method, and this is latte. Okay, what latte means? So as you can see, guys, latte is the abbreviations of some names of the functions. Yeah. First one is logarithmic. The second is arc. Arc means like arcsine, arctangent, arc cosine, anything, any arc function. And third one is polynomial. And this fourth one is trigonometric, and last one is exponential. Yeah. And which comes first will become u, the function u, the u that you see here. I mean, not you, but you. Okay. Okay. This is the part. that I'm talking about. Alright, let's solve one question, and I think you will know what I mean.
Yeah.
Alright, let's go down. Yep. Alright, so we have a function. It is asking us to find the integration of x times e to the power of minus x times dx. Okay, so can you use any substitution method here? Burak, do you think you can use any substitution?
I don't think, because there's nothing to substitute.
Yes, I mean, if you say like u is equal to x, then you cannot eliminate x there. You will have multivariable thing here.
Do you see 1? Do you see any 1? No.
No. So, okay, so this is the thing we are going to do. As you can see in the Lapte, it is logarithmic, arc, polynomial, trigonometric, and exponential. Okay, so we can say that x is polynomial, and e, the Euler's number, the power of minus x, and it is actually exponential. Which one comes first? Polynomial, right?
Yeah.
So we will assign x with u, okay? And then v prime will be e to the power of minus x. And if you take a look at the formula, like in the left-hand side of the equation, the original equation, we have u times v over dx. So in order to find the right one there, like we are putting v prime is equal to e to the power of minus x, yeah? So as you can see, as we did here, and this is v prime. So in order to find v, we have to take the integration, right? It is minus e to the power of minus x. This is the thing. So it will be equal to u times v, right? And u times v, we have them here. Yeah, no problem with that. We just put them here. And then we have minus. Just, guys, be careful about the signs here. They are very important. Okay, we have minus. In integration, minus e to the power of minus x. And also, I did not put 1 here because in the equation, it's asking us to put the differentiation of du over dx. So du over dx is actually u prime is equal to 1. So I didn't put it. And at the end, if we take the, and also let me remind you of that, these minuses will become negative. Yeah? These minuses will become positive, sorry. And at the end, if we take the integration of e to the power of minus x with respect to x, and it is actually minus e minus x. Because if you differentiate it, then you will find e to the power of minus x. Yeah? And then we have plus c, do not forget it. And as you can see, guys, we have this following equation. But can we take the multiple common factor? Yes, we can. And at the end, we have e to the power of minus x as a common factor times x plus 1 plus c. That is the thing. And secondly, guys, we have a great concept. Let's go down. Yes, thank you.
By the way, Ege, may I remind our viewers about one more thing? I asked them a question on chat. I said, at which part of Lapte does 1 come? Or dx come?
Yes. I was going to actually talk about that.
Okay.
We can actually, you can answer it if you want. I will briefly mention, guys, for example, if you want to take the differentiation of tangent x.
Or ln x. Anything.
ln x, yes. Anything. I mean, you cannot use substitution. You cannot use any technique. You can use 1 times tangent x. And what does it come as, Burak?
For example, ln x, it will be negative x ln x, sorry, x ln x negative x. If you want, I can solve it after your second example.
Yes, okay. I think 1 should come as polynomial.
Yes, it is polynomial. Yes. It comes under polynomials.
And guys, if you want to, like, it comes as polynomial and you don't want to explain it, but if you don't, then you should revise polynomials. Okay. Okay, so let's pass to the second example, and this is very important. Yes. And so we have find the integration of the power of x times sine x plus, and we integrate with respect to x. Okay? So we have trigonometric function and also exponential. Let's remember Labde. In Labde, as you can see, we have trigonometrics first. But why did I put u as... Burak, could you help me out here? Why did I put it? But I still solved it. I don't understand.
Okay, so just let me see it. Okay, I guess I see why. Do you mean so for the first part, IBP, the first IBP?
Yeah. Wait. Am I taking a look at... Yes, first IBP, yes.
So about the first IBP, well, this is an exponential. Maybe we should update it and post it on our Instagram account. Would it be fine?
Yeah,
okay.
I mean, guys, these priorities actually do not matter. Like, they matter in order to make your job easier. Like, you can actually solve it without using Labde. But if you don't use such a concept, then it will be okay. Like, it is just there to help you.
So, should I find the integral of ln x?
Yes.
So when we are finding the integral of ln x, just realize that in the equation over here you have times 1, right? Times 1 dx, or directly dx, doesn't really matter. So I will just say that ln x, this is logarithmic, right? Logarithmic comes first in Labde. So this is u, and this 1 dx is v, right? Because why? We said it is a polynomial. 1 is a polynomial, right? Just like it just has the power of 0. This is why we say 1 is a polynomial. So I will just say u is ln x, and u prime would be 1 over x. Therefore v would be 1, and we would say so this is v prime, so v would be just x, and v prime would be what? 1 dx, right? Then I can say that it could be written in the form of, we said uv, u times v, therefore ln x times x minus, we said u prime 1 over x times, we said v. Okay, so it would be x dx, right? We know that they will cancel each other out, and we will have x ln x minus integral of 1 dx, it is just x, and therefore this is equal to integral of ln x dx. This is how we solve it simply. Okay, so
yes,
yeah.
Burak, could you pass to the example I showed you?
Sure.
Before.
Yeah.
Guys, it is actually solvable without using Labde. I just remember I put this one as a reminder that we don't really have to use latte. Latte is just there to help you. Now I understand. I remembered. Okay, so guys, I put u as e to the power of x, okay, and v prime is equal to sine x. And if you use the formula of integration by parts, you will put ex times in minus cosine x minus ex times minus cosine x here.
Yeah.
And this is the first integration by parts. But guys, I should remind you about this. We have another integration by parts here, right? So we should apply another integration by parts. Okay, I wrote something wrong here. Let me remove it here and add ex times. Burak, I see what happened there.
Yeah.
My OneNote stopped synchronizing, and I wrote some equations wrong.
I see.
Now I remember, because I made a mistake at that point, and then I fixed it. Okay, now I understand. Okay, we have ex times sine x here. Okay, now I remember that. It is when we apply the second integration by parts. And when we apply the second integration by parts, we do another set of these, like u and v. And then we have minus ex times cosine x. We have it from the first function. And then plus ex times sine x plus ex. It's not cosine x, it is sine x. Okay? But at the end, guys, as you can see, and this whole equation is equal to, let me write it in a clearer way. X sine x dx is equal to actually cosine x times ex sine x, and we have the integration. Left. Okay. Plus, it is minus, sorry. Okay. Okay, let's finish it. 2e, and if we move this to the other side, 2ex times sine x dx, and we have e to the minus x cosine x and ex sine x, okay? And we put it to the other side, and it is minus 1 over 2 ex cosine x and 1 over 2 ex sine x, and this is the final part. We use double integration by parts, yes.
Right.
Okay, guys, we are going to change our Zoom link.
Yeah, okay.
If you could wait for a few minutes.
And it would be also like a break. We will just also take 2 minutes, and we will be back with definite integrals. And definite integrals are what? Important.
Okay, we will be back.
Alright, we are back. Yeah. Okay, viewers are 0 again.
Okay, I'm not surprised.
Yeah, well. So, time to start with definite integrals, right? So, again, what is a definite integral? Can you tell us about it a little bit?
Alright, guys. So, in definite integrals, we don't actually use constant integration. And as I said in the beginning of the video, integration is the area. It gives us the area function of a function, yeah? And if you put some definite integrals, and it is the interval, if you put some definite integrals, then you are going to find the area between those intervals. Okay, let's take a look at some examples. Okay. So in definite integrals, the first rule is that we put the higher value at the top and the lower value at the lower part. Okay, so, and also I forgot to mention something else, and I really like it here. Indefinite integrals, guys, if you find the, let's say it is b over a, and you take the f prime x, okay, this is going to give us fx, but it is going to be in square brackets, and also we put b here and a here, and we are going to substitute fb here minus fa.
Right.
This is the part I missed, and we will be including it in our notes in Felsefes in the card. Okay, and at the end you can actually also separate them, like in the integration identities I said at the beginning. Okay, let's solve one question, Burak. Okay, so the integration of sine 2x, and I told you about it, then integrating fax plus b. Okay, so if we take the integration of sine, we will have cosine 2x, right? But if you have 2x, you have to divide it by 2, because if you differentiate it, then you will have sine x, sine 2x at the x. Okay, but it also gives us the intervals. It is pi over 3 and 0. It's actually asking us the area in for the function sine 2x between the values pi over 3 and 0. Okay? Okay, so let's substitute our values there. Okay, okay, firstly, let's substitute pi over 3. And if you substitute pi over 3, then you are going to find minus 1 over 2 times cosine 2 pi over 3. And also substitute 0, okay? And if you substitute 0, it's going to be 0 and minus, in parentheses, we also have a minus. Just be careful about this, guys, okay? This is very, very important. And minus, and 1 over 2 times cosine 0. And at the end, we find that it is 3 over 4 units area. Okay, let's solve the example below. Oh, this one is simple. It is actually doable. Okay, so if you find, maybe we can let our viewers solve this question. But we don't have many viewers solve it.
Yeah.
Okay. Okay. It is. Let's take the integration of 2 times in square root x. Okay, so we have to add 1 to the power. Okay, and then we have to divide it by 3 over 2 by the increased power. Yeah, and then we are going to find at the end 4 over 3 and times x to the power of 3 over 2. And thus, as you can see, we can separate this equation like this. 3 over x, we can separate it like this. 3 times 1 over x. And the integration of 1 over x is ln x, ln absolute value. And it is 3 times ln x. And it's in the square brackets 4 and 1. And it is the easy part. Let's substitute them, but be careful about the signs. Okay, when we substitute them, we find that in the beginning, it is 28 over 3 plus 6 times ln 2. And that is our answer, guys. It is pretty simple.
So, Ege hocam, Mr. Bozkurt, Mr. Aybars, everything is fine with your part, but I have a question for you. Now, our viewers may ask, what if, always ask the question, what if we had an integration by definite integral by u substitution, definite integral with u substitution. What would happen? Would the same case work, do you think? Let's solve a question and understand.
No, it wouldn't, and Burak will show you how.
Do you want a difficult question or an easy question?
Let's start with easy.
Okay. My question is, please find the definite integral of between 2 and 3 being x over x squared minus 1 dx. Well, I think this is an easy one. Why? Now, obviously, we will be using u substitution. Why? I cannot use partial fractions. In the numerator, I have x, but I see that x squared minus 1. Let's call it u, okay? Let's call this one as u. Let me choose a different color, it would be better. Okay, this one. Let's call this one u. Why do I call this u? Because if u is equal to x squared minus 1, wouldn't it be the case that du over dx will be equal to 2x, right? And do I have an x in my equation? Yes, I do have it. Therefore, I can say that my integral will now be, I will not write here and here, okay? I will just keep them for you to answer it. Okay, so let's say x over u, instead of dx, let's take it here, dx is equal to du over 2x, right? Okay, so let's carry it here, du over 2x. x's will cancel each other, hence we will have, I will just leave those boxes like that, let's leave them, and we will have du over 2u, right? Du over 2u. Okay, let me say this will be equal to 1/2. May I take this coefficient right outside again? Right outside? Yes, why not?
Yes.
Because we are allowed to do that. It is just a coefficient. Du over u, it says. Well, now at this point we have to consider one thing. Mr. Bozkurt, did we substitute with u? We did, right? So my range for the definite integral was 2 and 3, right? Now some people may say, okay, let's write 2 and 3 here. No, never do that, because now your function is not fx, okay? Your function is not fx anymore. Your function is fux. So you will say that this is an important part, okay? You will say, for the x is equal to u, for x being equal to u, meaning this part over here, you will have u is equal to, you said x squared minus 1, right? Therefore, you will substitute this one as well. You have to define your definite integral limits by using the u substitution as well. If you are using u substitution, your limits should be defined by u substitution as well. Therefore, it would be nothing but e squared, 2 squared minus 1. It would be 3. Now let's look at the 3, the upper limit. It is x is equal to 3, right? Now x squared minus 1, let's substitute it over here. It will be 3 squared minus 1, and this is 8, right? Good. Perfect. Now I am able to say that with a correct green mark, this is 3 and this is 8. Now I can do my substitution. Now it is time to do the substitution. It will be equal to, 1/2 ln u in absolute value, and my definite integral limits are 8 and 3. Therefore, it will be equal to 1/2 ln 8 minus, let me take that in the parentheses directly, ln 3, okay? And it will be equal to nothing but 1/2 ln 8 over 3. Since in substitution or subtraction of ln functions, logarithmic functions, we know that a negative sign means divided. Did you see that?
And this is a perfect question, Burak.
I mean, this is important. If you are using U substitution, you have to inject it every single vein of your question, okay? Every single vessel. This is very important. The entire question looks something like this. Okay. If we understood it, I can pass to the next question. If not, I can solve one more question. I have one more. If somebody says I didn't understand it, I can. I'm checking the chat.
Okay, let's wait. Let's wait for a second because it's delayed.
Yeah, right. About 15 seconds, I guess, right?
Yeah.
Okay.
I think Gülşah is not here today.
Yes, I realized that. So who was the fourth person and third person as well? We previously knew about them.
Yeah, and I think she's studying HR physics today.
Yeah, actually, I guess we know the third person. The organizational edits Öztürk, I guess it's right. And perhaps Gülşah Hoca being in IB physics HL course. I guess again they understood it because they didn't ask anything on chat section.
Okay.
Area under curve, right?
Yep.
Okay. Your turn.
Alright, so it is very important, guys, and it's actually simple. Okay. And it's like the one we solved above for definite integrals, but using definite integrals we can find the area under a curve. Okay, but under a curve, we also above a curve or between two functions, and we will talk about them. Let's first talk about under a curve. Okay. Okay, so the question says find the area enclosed by the curve y is equal to sine 2x and x-axis. This is actually the same thing I wrote, but with pi over 2, not with pi over 3. Oh, guys, I will not solve it. Burak, let's pass to the second question because we already solved it. There's no point in doing it again. Okay, so guys, this question is very important, very, very important. Okay, so we know that the question says areas of regions contained by fx and x-axis. So I don't know that function. Burak, could you take a look at Desmos and
I'm doing it right now. I'm doing it right now.
Yeah, okay. Burak, let's wait for Burak. Okay. And
okay, I'm done.
Okay.
I'm just drawing the function.
Let's do it. It will make things clearer. You don't have to necessarily know it, but I will show something very important here. Because under a curve or above a curve may matter here.
Okay, so it is something like, again.
Guys, you see that? Alright. This is the tricky part. This is the part where you become a hero level. Okay? This is the part where Burak will talk about like above a curve, it will become negative. But, okay, so let's draw our roots. Okay, I think you're drawing, okay. Just -3, let me write it for you.
Okay. I just shaded the region that they are asking for.
Oh no, Burak, they are asking the whole region. Like
the whole region? Okay.
Yes. This is the tricky part.
So let me just shade it all.
Let's say this was asked in paper 1. Okay, you have. Okay, something is happening to my one, and I'm getting crazy. Okay. Okay. Let's say it was asked in paper 1. Okay, and if it was asked in paper 1, you may not have had access to a calculator, and you may not know. Which part is above x-axis or below x-axis. And when it is above x-axis, it is under a curve, right? It's going to be positive, but above a curve it's negative. So if you take the definite integral as -3 and 1, it's going to be a problem. You will find the area, let's say, this question is very important, I want you to pay attention to it more, okay? Let's say this area is A, and this area is B, okay? If you take the definite integral to -3 and 1, you will find the area like this. The area will be, the area is equal to A minus B. This is very tricky. In order to prevent that, and you should actually think about this one, like think about this situation when you are solving in paper 1, okay? You have 3 roots. So, it could be above a curve, under a curve. So let's take them separately, okay? If we take the roots of the function, we will find that it is x is equal to 0, x is equal to -3, and x is equal to 1. Okay, so let's take the A part first, the area A. You don't know it in paper 1, but let's take each interval first, okay? It is 0 and -3. And if we take the integral of it, it's going to be x to the power of 4 over 4. I don't want to remember this part because our focus is on definite integrals, okay? And if we put our values here, it is going to be 0 minus, be careful about the minus signs. And if we do the necessary calculations here, and we are going to find 45 over 4, right? But we have one more thing here. And this part is very tricky, guys. Be careful about it. It is 1 and 0. You put the higher value at the top, right? And if we do the same thing for this, we are going to find a negative value, guys. Why is it? Because above a curve is negative. But can area be negative, bro?
No, it cannot be.
No. With our current knowledge, no, it cannot be. Okay? So we are going to find 7 over 12. And when we add them up, we are going to find 71 over 6. That's it, guys. That is the trick here.
So,
and if you, yes.
Again, I actually want to show you what happens if our viewers take directly the interval from -3 to 1.
Yes.
This is what happens. You found 45 over 4, right? Your answer, final answer.
71 over 6.
Okay, so just a second. 71 over...
The whole answer is 71 over 6.
Okay, so now do you see? Look at the top one, okay? I took directly the integral from -3 to 1. Do you see how it is 10.7 and our answer is 11.83? 11.83. And now I will use a trick, okay? I will use a trick to show you how we are in fact right. I took the integral between 0 and 1, the point where Ege identified as B, being negative, and it is 0.583, and this is exactly the difference between Ege's and the real result.
Thank you for showing that, Burak.
You're welcome.
And guys, when you are using a calculator, be careful about this, okay? First draw the function, see it, and then calculate it, okay? This is very important. Burak, thank you for showing.
You're welcome. And to be honest with you, there is one more thing that I would like to identify. And for example, if you were given a question, it would be probably the last part. Let's design a question. Probably they would say, you are given this equation, find the first derivative, then the second derivative, then draw a sign diagram for fx, then f derivative x, and f second derivative x. Then they will ask you to draw the diagram. Again, you can see those kind of questions mostly in paper 3 or sometimes even in paper 1 and 2. And then at the end they say that, okay, you have drawn the diagram, let's take the integral. If you have the calculator, they are trying to bait you by just making you directly find the results. But you shouldn't be tricked. This is important.
Guys, when you have a calculator, just draw the graph. Let's see what the graph looks like, because we are humans like that. We are not computers. Let's see the function first and then do something about it.
Exactly. Right. Okay, so should I mention the area above a curve? I think I can. So about what Ege said, I will just tell you something very small about this. Let me write area above a curve. So when we are talking about the area above a curve, let's say this is a graph, and we have a function going in this direction. Okay, it goes like this. So we know that if those are the roots a and b, and if this is the reflection, I will draw it in green, let's say green. If we have its reflection on the x-axis, again passing through the same points, we can say that the area above curve, the red curve here, and the area over here are equal, right? They are exactly equal if they are reflections on the x-axis. So we just say that for the red area, let's say red area, when we mention about red area, while you are using the calculator or using your logic, you have to be aware of the fact that by assuming it and knowing by heart that the integral of this area will be negative between a and b, fx, let's say, dx, and this is also equal to y dx. Why we are multiplying by a negative sign? Because for the red area it is negative. It is exactly as same as green area, let's write. Therefore this will be equal to the area of BA between, let's say, f green x. Right? Anything I'm missing again?
I don't think so.
Yeah. So for example, if you are given, let's say, a sine diagram, okay, sine diagram, and let's say this part is 2 pi, right, pi. So if you were to take the integral between 0 and 2 pi for sine x dx, what would it be again, do you think? 0.
Yeah. Yes. And
exactly. Because this area is equal to this area. Therefore, it will be the green area minus the red area. That's why if you are given a diagram, like for example it says the distance curve, and we will be actually studying them in applications of differentiation and integration, so please just imagine the graph in your mind to have a clear idea. Okay, can we proceed with area between two functions?
Yes, that's correct. Alright. Guys, in area between two functions, we are going to use two things, okay? The two things Brock mentioned right before this topic. Okay, so in order to find the area between two functions, firstly, you would find the area of fx, right? And you cannot put plus, right? So gx, because it is above a curve and it's going to be negative. So, in order to find the area between two functions, we say that it is integration and b between b and a, and it is fx minus gx plus dx. And actually here we are finding, we are putting the positive value as at the top, and the negative value will be the one that is at the bottom. Okay? In order to find that, for example, like IB may give you an equation, okay? Show you an equation and find the area between some points. In order to find the area there, you let's give values, okay? Give values, and the one to the functions. The one that is higher will be at the top, so you have to put it at first as positive and the one at the bottom as negative. So that is the one way to figure it out. Okay, let's solve one question. I think it will be enough. Okay. So it's asking us to find the area of the region enclosed by y is equal to x plus 2 and y is equal to x squared plus x minus 2. Okay, let's find their roots, okay? Let's find their roots where they intersect. This is the enclosed by. When it says enclosed by, think of it like the one function and the other function is intersecting at a point, and they form an area between them in the interval of their intersection. Okay, and to find the intersection, we have to equate them, and when we equate them, you can see that we have the function x in the root as x minus 2 and also x plus 2. Okay, so let's put, but you may say, what if one is down the curve? It could happen. Maybe, Burak, could you show us the graph?
I am doing it right now.
Okay, could you help me with that? Yeah. I would appreciate it.
So our graph looks something like this. This one should go exactly in this way, and then the other one is as well. I can zoom, okay.
Yep.
Sorry, let me use another color. Okay. 2, negative 2, 0. Yeah. Okay. And any other points that you want me to identify?
No.
Okay.
We found out that our point of intersection is minus 2. Okay. Wait a sec. It should be minus 2, isn't it? Okay, never mind. Let's say we are finding the area here. It is not above the curve. Like in area between two functions, area under or above a curve does not matter actually, guys. It does not matter because you are putting it as minus. I mean, you are not finding the x-axis or y-axis, so you just need to put them, as you can see in Burak's graph. And this showed us that you don't have to worry about which one is above or up a curve.
If you find negative, just switch it.
Yes, exactly. Okay, so let's put our roots, okay? Because it is enclosed. It's 2 and minus 2 and integration, we just put it. The upper function is x plus 2, okay? So in order to find that, for example, we know that it is enclosed by minus 2 and plus 2. And this is the part where when I was trying to say which one is at the top. Okay, let's say you are in paper now, okay? Let's give them 0, because it's in that interval. If we give them 0, guys, one is going to be positive, this one, y is equal to x plus 2, it's going to be 2, but this one is actually minus 2x. This is their y value, so this first function, y value is at the top, so this one is at the top, okay? And it's x plus 2 minus x squared plus x minus 2, and it is dx, we are integrated with respect to x. And then we just simplify it, and then when we simplify that, we find that 4x minus x cubed over 3. In square brackets, you need to put those square brackets in order to be mathematically correct. And then when we put 2, okay, when we put 2, 4 times 2, minus 8 over 3, minus, but we are putting minus here, guys, minus 2.
Yeah, minus
8 is minus 8, and also it's going to be plus because we are putting minus here, it is cubed, so these minuses will cancel each other. And then we have 8 over 3, okay? And when we do this necessary calculations, it's going to be plus 8 and it's going to be minus 8 over 3. It is 16 over 8, 16 minus 16 over 3. And then at the end we have 32 over 3. That's it, guys.
Great. So Ege Hocam, Mr. Aybars, Mr. Bozkurt, an important question. So you taught us how to solve the area between our graph and the x-axis. But what if we were given the area, we were asked the area between our curve and the y-axis? What would we be doing? Actually, the answer is pretty easy. Now let's say area between curve and I will say y-axis. When we are talking about this area, I will just give you a quick example to show you how we are just reversing the places of x and y. Okay, so the question says find the area between fx is being equal to root x minus 1 and y-axis between, let's say, y is equal to 1 and y is equal to 2. Okay, y is equal to 1 and y is equal to 2. So if you are asked this in paper 2, you already have the graph, so you can visualize it much better. You don't have to imagine, but this is already an easy graph, so you are already engaged with the root functions, so no problem. But let's say for the solution parts, let's say we have y is equal to root x minus 1, right? Do we know how to take the inverse of a function? So, Ege Hocam, if we find the inverse function and if we take its integral, wouldn't be the area between now y-axis and the curve? It would be, right? It would definitely be. Let's see how. Let's say I'm now trying to leave the inverse y as the only element on one side. So we will take the inverse. Take inverse. While we are taking the inverse, we are switching y with x and x with y. How? Let's see. So while doing that, I will write x is equal to root y minus 1. Okay, so I have to solve for y to find the inverse, because now in this case y means fx inverse. Then x squared is equal to y minus 1, am I right? Then can I not say that y is equal to f inverse y, and this is x squared plus 1. I just solve for y, where y is the inverse function. And now I will say I will take the area by taking the integral between, it was saying 1 and 2, let's write 1 and 2 over here, and then I will take x squared plus 1 times dy, this time dy, because now I am trying to get engaged with the area between y-axis and the curve, not the x-axis. If it was the x-axis, we would say dx. Okay, so let's say this is x cubed over 3, right? And to be honest with you, I would prefer saying y for this one. Okay, if we set for y, let's keep it with y. I would say y cubed over 3 plus y, and what was our range? 2 and 1. Then, when I make the necessary calculations, 8/3 plus 2 minus 1/3 and minus 1. You just do it, you have the calculator or your mind to solve it. Then this will be equal to 10/3 units. Let's see if we were correct or not. I will just draw a graph over here to show you that we were right and how we did it. So I will just choose this color. This is the graph that we mentioned, where this is 1 and this is fx being equal to root x minus 1, okay? Root x minus 1. The question was asking the area between 1 and 2. Y is equal to 1 and y is equal to 2, they were asking for. So, again, this is the area they're asking for, right? This is exactly the area that they mentioned. Therefore, I can say that we found it. We definitely found it. We took the inverse for y, f inverse y, and then took its integral. And remember, if it was a u substitution, apply u substitution at every single point that you see it. It is just like the continuity of chain rule in every single part. So please be sensitive about this. Hence, or otherwise, you will be losing marks which we really do not wish to have as an issue. Therefore, I just took the inverse, took the integral, used exactly the same limits and ranges, and found the area over here. This is 10/3 units. Units square or something.
Burak,
Yep.
we don't have much time for Zoom. Guys,
Okay.
we will switch our Zoom meeting. Please wait. We have 5 viewers now. Please
Wow.
wait.
Yeah, please.
Just a second, okay?
This is a record.
Just give us a second.
We will be back. Okay, we are back in business. Actually, always in business. Okay, we are back in business. So, again, so you will carry on with solids of revolution, right? I guess.
Yes.
Okay, solids of revolution.
Okay, so solids of revolution, and it is the topic which IB likes, and they are usually worth 3 marks.
Yes.
Like, it is typical. I mean, when you see a calculus question in section B, you will most likely see a solids of revolution question, which is worth 3 marks. Okay.
He's right. That's a point.
Okay, so in data booklets, they say volume about x-axis is dA as definite integrals, and it is pi times fx square. And this is actually y. Fx means y, not x, guys. And it is dx. Okay? And then for y-axis, it is dA pi times f inverse x to the square and times dy. Okay? Let's see what they mean. Okay? Let me write you a question. Let me write you an example. And I like this example, guys. Okay? Okay. Example says, find volume of solid. Okay, solid formed. Then let's write an equation. Y is x for the interval. And it is revolved by 2 pi, about the x-axis, guys. Let's think about it. This function is actually like this. Okay? And then we have 0 here, and let's say 5 here. It is not square, okay? And then this is our x-axis, right? This one. And also, guys, as you can see, it is being revolved. Let me draw it in a different color. It will make more sense. Okay. It is being revolved here actually. It forms this shape. Okay. This is the logic actually, and this is extended to the 0. I'm not a good drawer. Maybe Brock could draw a better one. I don't know. But this is the logic. Okay, let's solve the question. In question, they already give us the interval, okay? All we need to do is just apply the equation. Okay, we know that it is 5 and 0, yeah? And then it is pi, and what was the equation? It is fx squared, right? Because it's fx squared, we are going to like y squared dx. And this is actually equal to, my one is going crazy, and this is actually equal as to pi. Let's write pi outside, okay? Because we said it. It is a constant, not a variable. Pi, and it is x squared, yes, isn't it? And then, if we put, it's not x squared, guys. It's x to the power of 4 dx. And when we do it, we will find that pi times x to the power of 5 over 5 in square brackets, and it is 5 and 0. And if we do our calculations, we will find that it is pi times 5 to the power of 5 to the power of 5 over 5 minus 0, and at the end we will find that it is 625 pi. And these will cancel each other actually, and it is pi to the power of 4 at the end, or pi. Yeah? Yep. This is the logic, guys. And there is one more, and it is revolution about the y-axis. X-axis, and okay, let me copy this part, guys, because I don't want to waste your time. Or let me draw it. Find volume of solid formed when the y-axis, guys. And this is the part where we use what Brock mentioned us, like finding its inverse. And we have this graph, y is equal to L and x. Yes, Brock is actually drawing us. Okay, y is equal to L and x, and it is revolved to y. So we are going to take all of it. Okay, good. Let's see. It is okay. Let's keep it 2 pi, and I will mention something else. Let's see. Okay, it is x is equal to L and y in order to find our function at the end, and it is e to the power of x is equal to y, and it is actually equal to f inverse x. Okay. Okay, let's put our answers. Okay. And guys, I forgot to put the interval actually. It is 1 x and e. But guys, it is asking y-axis, isn't it? If it is asking us the y-axis, we have to find the interval in y-axis then, because we are revolving it y-axis. If we put y here instead of x in our interval, then we would apply it as it is, right? But for here, no, we are not. We are putting x. Okay, let's solve our equation. I actually put it in per page to convert it. And we will find that it is pi, and let's put 1 here, okay, in our original equation. E1. It is E. Actually, the lower part of this is actually the higher part of it. This is ED. And if we put e to the power of e, then what's going to and it is e to the, let me write it. It is, guys, I wrote the question incorrectly. It is y. Sorry about that. Very sorry. This is my mistake. We are putting it as it is. It's e and y, and it is the square of dx, right? And dx. What Burak wrote in terms of y, but you can actually turn it into dx. You can write it in different forms, no problem. But y, it doesn't matter. It's how you express it at the end. It's pi, and if you take the integration of it, it is e to the power of 2x. And let's take the integration for that. And it is the integration for e, and we have 2y here and also over 2. Okay? And we put our integrals. And when we do that, we will find that it is pi, and then is e to e over 2, also minus e to e's cube, and then it is 2.
Yeah.
This is our final answer.
So may I ask you something?
Yes.
So may I make a geometrical proof about this formula given in the data booklets? By this way, maybe they can understand why we are taking the square or multiplying by pi or multiplying by dx. May I quickly do that?
Yes, Burak, also I want to mention something
Yeah,
else.
sure.
Guys, let's take the situation where it is like one, the interval is write it in a different color, where it is 1 and x and e. They give us the x value, okay? Burak, I will mention it very quickly.
Yeah, sure.
Yeah. Guys, in this part, we will put it as here. It is actually ex and 1, and x is equal to 0 here. And also, let's put e here, and x is equal to 1 here, isn't it?
By the way, I guess there is a huge lagging problem about OneNote right now. Is it?
No, it's not. Oh my god.
Yeah.
Stop synchronizing.
Yeah, right. Exactly. May I make my advertisement once again?
Okay, Burak, you can do the geometrical proof.
Okay. Until it comes,
We are
right?
going to solve this question.
So I will just write proof over here. So how we reach to this answer? How we reach this? So let's imagine that. We have a curve like this. Okay, so this is our y-axis going through that, and I will just draw our x-axis like this, x-axis. And now let's say that we have a curve that passes through, it's like that, and I will say this is y is equal to fx, goes also in this direction, and then also its symmetry or the x-axis, again the same one. But now let's say that I want to find the area of solid revolution. Solid revolution means that I have this curve over here, but this is only in one direction. It is not three-dimensional. So let's think that What if I just turned it around the x-axis to find the area, okay, between, let's say, point A and point, let's say, B, okay? Thus, I had an area just looking like this one. Okay, so I'm looking for this area, okay? This looks like a vuvuzela. This looks like a vuvuzela. This looks like a horn as well. So I'm looking for this 3D shape area, volume, actually, not area. Thus, we can say that let's imagine those are tiny disks, okay? Tiny disks, but very small disks. So there are like, this is like a disk, okay? A tiny disk. And let's say it has the width h, okay? This is the thickness of a disk, each disk. Now, I can say that, don't I know that the radius of this disk, meaning distance from its center to here, would be xi, right? Xi. The x value would give me the radius, because when I plug my x value, I will have the y value directly, and y value gives me the radius over here. Therefore, I can say that there are infinitely many, okay, infinitely many disks in this vuvuzela shape, horn shape. Now, I will say sigma, I will calculate their volumes, okay. I know that if I have a disk, its area would be pi r square, right? And its volume will be pi r square times h. Now I will say pi. What is my r value? My r value was this one. So I will just say, I will just recall it as f xi to the power 2 times my h, okay? This is the r, this is my pi, and this is h. Okay, so I have used sigma over here. Why? Because I am trying to find the sum of it. Now, to find the volume of revolution, I will say volume of revolution. By the way, do we have any questions from chat regarding this? I guess no, right?
Let's see. No, as always.
I said infinitely many disks, right? Infinitely many. So again, imagine you are looking for infinitely many disks between A and B. What would you expect your H to be? The thickness of your disks. Almost zero, right? Approaching to zero, to make them infinitely many. To make sure that fits in infinitely many disks fit into this volume. Therefore, I will say limit h will approach to 0 to make infinitely many. Sigma. And I will say I over here, and it will be pi, as I said, f x I, meaning our radius, squared times h. And we know that sigma notation can be shown in this way as well. When we are talking about sigma and integral, between the relationship between them, if h is approaching to 0, now I will say between b and a, my range, the volume for my range, pi, now I will say f x square. Why do I say x? Because I am looking for all x values, not a definite, not an exact, not a certain disk. I am looking for all the radiuses that range between a and b for my function fx times dx, okay, due to my limits. And at the end, we know that pi is a coefficient, so pi could be taken out of the integral, and it would be the case that fx square times dx. Again, was it the answer that you have found?
Exactly.
This is the proof. This is how we prove it. This is it. So still not synchronized, right? Still not synchronized, right? I guess no.
Let's try it, Brock.
Okay.
I will draw something. Where did you draw this? Oh my God, Brock, we are in the wrong document, man.
Wrong document?
No. Wait.
Let's see what will happen.
Where did you draw proof?
I drew proof right below the example that you have drawn about the source of
I cannot even see it.
I see. Okay, I see.
We will fix this problem, guys.
Okay. Anyhow, we can share it on Instagram account, okay? Or either on our website. If we had made any mistakes or told you that we will share the example with you, we will just share it on our Instagram account just as we did for our physics examples. So, the final thing, it is my topic. It is about solving problems by using integrals, right? Problem solving by integration. Now,
and Brock, we have one more thing. It is improper integrals. It is very
improper. Right. So about the integral problem solving with integrals, there is only things that I would like to say. Make sure that you can imagine what is told to you, understand the concepts that is given to you, try to use substitutions if you cannot do anything. And the problems are actually pretty basic. For example, it says there is the rate of power consumption of a city and it is modeled by this function. Then they say, okay, please find the energy consumption between the time, let's say 1 p.m. to 3 p.m. and then calculate this one and this one. So just make sure that you are applying all the integration laws correctly, either substitutions or general rules, and follow the definite integrals laws also in the same sensitivity. And as you do that, you will reach the correct answer. Now we have improper integrals, right? Well, will you be able to annotate it again?
Yes, I guess so.
Okay, so I will just let you annotate and we can take the screenshot and share it, okay?
Alright.
But let's not annotate here, let's annotate over here, okay? I just let you annotate. This is the last thing, by the way, guys. Improper integrals.
Then it will be over. We know that you guys are tired. Yeah. We are also a bit tired, but it's the last thing, guys. Hold on, okay? Try to hold on, okay? Let me go full screen. Alright. Okay. So, guys, in improper integrals, we have such equation. Let's write it. To the infinity, and it is any value a, and it is fx dx, and at the end, actually we can write this one like this. Let's say it is e, okay, going to infinity, and sorry, I haven't drawn it correctly. It's EA, and it is fx dx, and it is in this range. We can actually write it like this, guys. It's going to make our lives easier. Okay, let's write one again. And you will see what I mean. Okay, so we have a function, and this function is to the infinity and 2, and it is 1 over x to the power 4 times dx. Okay, let's. Okay, so guys, what do you think is the answer? You may not predict, but of course we can use the equation that I showed you. Okay, let's say we have a limit, and let's this give value at b, okay, and it is going infinite. And in this limit, guys, we know that this integration is approaching b. It is between the interval b and 2, right? And then we can write 1 over x to the power 4 times dx. Yeah. Okay, let's take the integration first. Okay, in terms of b, guys, in terms of b. Let's write the in terms of b, and you will know what I mean. Okay, let's do the integration here, guys. It is, let's say, we are increasing by 1, right? It is x to the power of minus 3 and over minus 3. And in square brackets, b and 2. Okay, let's come for our limit. Let's put it in. X to the power of minus 3 and minus 3 in square brackets, b and 2. Okay, let's write this square brackets. Okay, and you will see the magic. Okay, let's write square brackets, and it is, let's put b here. Okay, this b is actually will go down, isn't it? Okay, let's write it, guys. It is 1 b, it is we have minus 1, by the way, to the power of cube 3, and we have also 3 plus, let's not put plus, it will confuse you, minus 1 to the power, we have 2, we are putting 2, 3 and 2 cube. Okay, and this is actually plus. Okay, these will become plus, and at the end, guys, you will see that as b is approaching infinity. Right, what would happen? We mentioned it in our limit video. What would happen if b is approaching infinity and b has a power of minus 3?
It goes to 0 because we are dividing it with a huge value.
Yes. If you divide 1 by very huge value, you would get something very close to 0. You can try it in your calculator. Okay, put 1 over 1 trillion. Okay, you will have something very close to 0. Okay, it is approaching 0, but we have plus, and we are going to put our equation here. 3 times x, and it is equal to 1 over 24. This is the answer, guys. This is the answer.
They cannot see the answer. Just a second. I will arrange it accordingly. Okay, now they can see the answer. This is satisfactory, by the way. This is pretty satisfactory. And this is the reason why, by the way, we have to get familiar with the idea of limits.
Exactly.
Limits has an importance due to this. I took the screenshots. We will be adding that to the notes. No problem.
Okay. We would have one more question. Okay. Let me write this question. I will not fold it. Okay.
Okay.
It will take a bit time, but I will show our viewers how to solve it. Okay. Okay. We have an integration, and x times e to the power of minus x times dx. Okay. What are we going to use here?
I guess we will be using integration by parts.
Exactly, guys. Exactly. This is the thing. We are going to just put b to the infinity, and then we have this definite integral, and then we are going to use our definite integral here, integration by parts here. And then when we find the integration by parts here, we are going to put b we will approach infinity, and then we will find our results accordingly.
Definitely. So let me just go back to my original position like this. Yep. So do we have anything else left?
I don't think so.
Okay, so let me just go back to a motivating page, just like this, okay? This is, I think, a motivating view. I will also position myself over here, over felsefesinde. So, everybody, do you have any questions? And even if you don't have any questions, maybe you can type on chats for chit chats. Doesn't really matter.
We can have a bit of chit chat.
Yeah,
we are also humans, guys. We are not math computers.
We are a little bit bored as well, so it would be nice to hear from you. How are you doing? How is it going so far? Do we have only 12th graders?
11th graders.
My favorite sweet. It is, I guess, sheep, but little sheep. Okay, I like them very much. Little sheep, yeah. It's how it's called. They call them also mini sheep as well. What's yours again?
I like the dessert that my mother does. It's like you're putting a cream into a glass, and then you cover the top with chocolate.
Okay,
and
I see.
You put it into refrigerator, and like the chocolate, and you put layers of biscuits.
Yeah. Okay, yeah. It's like mosaic, right? Mosaic cake.
Yes,
kind of. I see. I understand what you say. Okay. Yeah. So any other question? Yeah, please, let's just chat. Let's convert it back into Twitch. Let's watch Ramanujan solving one of the most difficult theories and comment on it, reaction to reaction.
It would be a very good reaction video, which would be suitable with our concept. Right?
Perhaps, yeah, definitely. Maybe I can do book suggestion. What do you think about it again?
Yeah, let's do it.
Just wait a second. Okay, I'll be back.
Okay, guys, who are our viewers? I mean, we know that Zeynep has been watching us frequently, but we don't know anything about the other viewers. I saw Öztürk at the top. I think he is from our school, but I don't know him. I don't recognize him from its name, I mean.
Okay, I'm back.
Nobody is writing.
Yes.
They're just watching.
Please type something. Okay, again, actually we talked about it previously, this book. Do you remember that? Or do you see this? Okay, yeah.
I cannot see it, bro. You should also open your camera. Yeah, okay.
Yeah.
Alright. Oh my god. This should be our book in summer when we finish IB.
Well, this is great, okay. It's called Kuramsal Başlangıç by Leonard Susskind and George Shropsky. So I actually checked their profile and they're really doing advanced jobs, and they're saying, for example, like introduction to things that you should know before starting to do physics. And you see that although this is a physics book, I see nothing but mathematics. And the concepts that we have just discussed, like derivatives or integrations, they're all here. Or like sigma notations, do you see them? Sigma notations. They're all inside. So once you start to get familiar with those concepts, you see that you are using only Greek letters. And once you start to see Greek letters more than the numbers, it is the point where you start to understand things. You know, like when you start to quantum physics, you see phi, you see like C, you see like alpha, beta, theta. all those Greek letters, and this is pretty perfect. This is perfect. So I really suggest this book. I enjoyed reading it. You can take notes onto that, and you can learn more than that. And please, again, I'm saying that this is not the advanced, the uppermost level math that you will be doing so far. When you go to college, you will go even further than that. And whatever you study, you'll do that. So I'm checking the chat. Okay, so Zeno, what's your favorite dessert? Which one do you like the most? Let's hear from them as well. Let's see what she will say. By the way, are 2 other viewers enjoying this moment?
Yeah, they're just listening.
And we don't know who they are. This is actually a little bit...
Oh, it's 5. It's 5 now. Okay, whoever this new... Okay.
Yeah, some... Oh, left.
Okay.
No, they...
Okay.
Okay, Zeynep said, a dessert that is special to Sivas and not much people know about it. Okay.
Is it shirdan?
It's not special to Sivas, but I guess what that is, something special to Sivas. Nice, I like this answer. So, okay, any other question? By the way, I like this answer. It's pretty sweet. Yep. Anybody? I really wonder. Again, now I really wonder who is that person? Who is that other 2 person? Literally.
No idea. I think they're both. I don't know.
Yeah, perhaps. They are literally watching us. No way.
Okay.
So should we call it a day?
Yeah, let's call it a day.
Okay.
I know you guys are tired. We are also tired. It was a good one.
By the way, again, today I will share a post. How a felsefesinde content is produced.
Okay.
Starting from the 0 points, I will share a procedure about that. I hope you will enjoy it. We will be sharing again our class notes with you on our website. We will be sharing some of the problems that we couldn't share with you today on our Instagram account as well. Please follow up our Twitter account as well. And we shall call today. Anything you want to add again?
No. Guys, please stay safe and study hard.
Stay tuned, enjoy the vibe, study wisely, study hard, however you like to call it. Mock exams are coming up, they will show up soon, and we will have strict live video streaming calendar as well. So please follow up, stay tuned. We will be sharing more with you soon. See you, bye bye.
Bye bye.
Bitmedi Allah, bitmedi.